Hello, everyone. This is Cameron Smith from TechLogix, ready to go through another webinar with you this morning. For folks who's never have attended one of our webinars in the past, and we try to do these on a pretty regular basis, we're going to be going through a handful of slides here. If you have any questions, please type those in the little question box on the webinar widget, the GoToWebinar widget that should be on the side of your screen. Also, there's a handful of downloads. So we've got some handouts that go along with this presentation. We've got our Fiber Pocket Guide, which is a good introduction to why fiber, how to use fiber, where to use fiber. We also have the slide deck. So if you see some information that you're interested in or you want to take with you, you can go ahead and download that slide deck that's available. After the webinar, everybody will get a follow-up email. You'll see my contact information. You'll see some information on our team and the links for any of the next steps that you need. With that, let's go ahead and get started. Today, we're looking at the ensuring integrity with fiber optics. This is really a webinar that's all about troubleshooting. Obviously, there's a lot of moving parts to fiber. A lot of people who are just starting to get into fiber optics, they're looking for some best practices that go along with how do I wire, how do I create a good infrastructure, how do I troubleshoot a run. We're going to talk a lot about that today. And, you know, all of this starts with learning how to terminate. We've got classes on how to terminate. We've done those pretty regularly, and you'll see upcoming schedules of other webinar topics. Everything from designing the system, acronyms, how to sell fiber. That's a very popular session that we have as well. That's all on the website, tlnetworks.com. But with that, let's go ahead and get started. I always like to start with why fiber optics, right? We've seen fiber for many, many years in the networking world. We've seen fiber in the commercial world, but in the residential world, the CI industry, this is just starting to explode, and there's a couple of different reasons for that. Really a big factor right now is all around 8K. You know, we've been talking about 1080p, we've been talking about 4K, HDR, but now 8K is starting to be released. We're actually seeing 8K displays and projectors shipping. And 8K, for everybody who's in the AV industry and has kind of been following this, you know that the bandwidth required for a maximum 8K signal is 48 gig. Cat 5, Cat 6, even Cat 6A, the cables that we've been using for decades, these cables just don't handle that bandwidth. They max out at about 10 gigs. So to take a 48 gig signal and effectively run that any distance, we got to start talking about fiber optics. And the cool thing about 8K is we're also delivering the signals in a different way than we're normally used to seeing our video. Right? If we think about our homes, we tend to think of watching TV as a broadcast standard. 8K is a little different. It's a streaming standard. That's how it's being packetized. It's how it's being set up. So as we talk about 8K and we talk about the need to move the video and watch the video and really take advantage of all the cool things that 8K brings, we also have to be cognizant of our networks, because our networks need to move those data packets from point A to point B. And on top of that, we're seeing a huge explosion of connected devices, not only in the home, but obviously in the professional markets. So these bandwidths, these networks, they need to be looking at fiber optics too. And as we start to get into fiber, as you start to embrace this, what you'll find is fiber is a great way to obviously future-proof. I mean, these cables have virtually unlimited bandwidth. It's 10,000 times more bandwidth than a copper cable. That's what a fiber optic cable, an OM3, an OM4, or an OS2 can handle. A lot of bandwidth. It's the electronics that haven't caught up. And this new infrastructure, this new disruptive technology, it is future-proofing. It is a way to drive profitability in your business, to differentiate your company from other companies who are still pushing twisted pair. And as you look at the future technologies that are coming, and 8K is only one of them, fiber is really going to let you leverage those. So there's a lot of reasons why people are looking at a fiber optic infrastructure and fiber optic cabling, and now the fiber optic electronics in their professional installations. But there's a lot of things that go into this. It's not as easy as, hey, buy a fiber cable off the shelf, plug it in, and I'm good to go. You do need to take some considerations in mind when you're designing these systems. What kind of cable we're going to look at. How is that cable construction? What are the physical properties? There's different types of fiber. We'll talk about that here. What kind of connectors am I going to use? Am I using a Premade cable, a bulk cable? And really importantly here, what am I doing with the installation? What's plugging into that fiber, and is it compatible? So as we start to think about all of these different variables, it drives our decision making, because obviously a well-crafted system is going to have a lot less troubleshooting in the future. You design the system right, you install the system right, you're not really going to have a lot of issues and troubleshooting down the road. So let's start with selecting fiber, and I apologize if this is a little basic, but this is usually where I like to start out, because for folks who are new to fiber optics, there is a difference between single mode and multi-mode. And, this is, a lot of people will compare this to the different grades of twisted pair. It's not really quite that easy. So from a most basic level, how do we select our fiber? Single mode is the cable that you want to think of for those longer runs, right? This is the cable that will literally push your signals miles, kilometers. We're looking at networking gear that'll use a off-the-shelf single mode cable and drive those signals 20 kilometers, okay? Single mode is for that long distance, whereas multi-mode, it's for that shorter distance. Multi-mode fibers tend to max out at about 1,000 feet. And the limitation isn't the fiber, right? Keep this in mind. The fiber is future-proofing. The fiber has a lot of characteristics, but it's what you plug into the ends of it that's fairly limited. Now, this is a little counterintuitive, right? Because people think, all right, single mode fiber, it goes longer, must be a bigger cable. Multi-mode fiber goes shorter distance, must be a smaller cable. It actually doesn't work that way. So if we look at the physical properties of the fiber optic cabling, what we find is a multi-mode cable is actually a bigger piece of glass. It's got a bigger core size, whereas a single mode fiber, that's a smaller piece of glass, a smaller, thinner core size. And this has to do with optical properties, wavelengths, right? If you think about a wave of light, a beam of light, that laser that's going through the fiber cabling. In a big piece of glass, those phases, those wavelengths can get out of phase much more easily than in a smaller piece of glass. So that single mode cable that you're working with, being a smaller piece of glass, keeps those signals in wavelength, in sync, much longer distances. And this is why that single mode cable with off-the-shelf components will literally push your signals miles, whereas that multi-mode cable, that bigger piece of glass, it's a little bit more limited in distance. Now, you can send more signals through that multi-mode cable. You have more bandwidth over the short run to work with, but you are limited to 1,000 feet. That's the easiest way to differentiate these two cables when you're starting to design your different installations. Single mode over 1,000, multi-mode under 1,000. Now, you can certainly use single mode under 1,000 feet, and actually in a lot of commercial applications, data center applications, it's all single mode. We do a lot of work out in Las Vegas and these large casinos. It's all single mode, right? And part of that's because they go long distances, but part of it is they just standardize on one cable. That is okay. Just know that the electronics that plug into your single mode cable, that smaller piece of glass, they tend to cost a little bit more money, whereas multi-mode electronics are less. Now, cable grade also plays into this, and there's really a handful of different grading of cable, and this is kind of a standard out there in the industry. So there's two types of single mode you'll run into, OS1 and OS2. And the different types of fiber, that OS1 versus the OS2, really has to do with the physical construction of the cabling. For the most part, OS2 cables are loose tube, meaning that their construction isn't as tightly constrained when they're making the cable. That fiber inside is not as tightly constrained. That means the loose tube construction cable performs better in outdoor environments, environments where you're going to have freeze cycles or weather fluctuations. That's where loose tube really excels, and that's also why you see a lot of OS2 being pulled as the standard. Now, in a multi-mode, that larger core size, larger diameter fiber. There's OM1 and OM2, which is LED optimized. But what we tend to see is people are standardizing today on OM3 and OM4. These are the laser optimized grades of fiber. And these signals that are going through the multimode, they really perform best in an OM3 and an OM4. And frankly, that's what's going to be future-proofing your installations. Now, I always like to show this chart because this is a Bixby standard chart. This is going to show you, from a Bixby point of view, how a cable is going to perform given bandwidth and given distance. And what you see is if we're talking about 1080p, if we're talking about 4K HDR or even 8K, we really want to be looking at an OM3, an OM4, or an OS2. Just like what I was saying, these are the ones that we tend to standardize. Now, I said that this chart's a little misleading because this chart doesn't just look at the optical glass, the cable. This chart also is taking into account the electronics that are plugging into those cables. So the electronics today, mainly for networking, that's what Bixby's looking at, mainly the networking world. They do have a limitation in terms of bandwidth over distance. But when we extrapolate this and start to look at things in the AV world, like 4K HDR, 8K, we can actually push our signals further than what you're seeing on the charts, right? We're pushing 4K HDR signals today, kilometers, no problem, using single mode cable. We're going 1,000 feet, no problem, using the OM3 and OM4 cabling. So I like to use this chart because it's a standard industry reference, but it doesn't tell this whole story. Future proofing really comes with the cable. The electronics continue to catch up. Now, the next part of the conversation really turns to the cable construction. There are different types of fiber when you're designing a system that you really can optimize to create an ideal infrastructure, an ideal installation, right? Simplex is the most basic fiber. And, a lot of people tend to talk about the different strands inside of fiber as conductors. You're really not conducting anything. That's one of the things about fiber optics. There is no power transmission, right? Now, the good news is that makes fiber cabling immune to electrical noise, electromagnetic noise, RF interference. It doesn't worry about things like lightning strikes or static electricity. Fiber is non-conductive, okay? So you don't have conductors. You have strands. And simplex fiber is one strand, okay? Duplex fiber is two strands, typically in a zip cord construction. Now, here's the thing. A lot of electronics, especially when we're talking about extenders, they can use simplex fiber. They will only need one strand to operate. And that one strand of cable can bidirectionally send signals back and forth, okay? But I caution everybody, never pull simplex fiber. You just don't really want to do it. And the reasoning is because simplex fiber is not future-proofing your installation. In a networking world, you almost always need bidirectional communication on two strands of fiber, duplex at a minimum. So even if your devices today call for simplex, pull duplex at a minimum. It's going to future-proof your installation. It's going to let you upgrade in the future. It's going to be far more flexible. If today you may be using that fiber for AV, tomorrow it may be networking. 2 years from now it may be something else. Pull duplex at a minimum. Now, there are multi-strand cables available, breakout fibers, micro distribution fibers. The difference is really how much jacketing, extra jacketing, is on those individual strands. So a breakout fiber has a heavier jacket, so those strands have more protection. So when you unzip the bigger outer jacket, you can run those inner strands longer distances. Whereas with the micro distribution, you really got to go into a breakout panel or a patch panel, right? You don't have as much protection on those individual fiber optic strands. So just two different ways, two different types of cabling that you can design your systems with. Simplex one strand, duplex two strands, and then you get into the multi-strands of breakout fiber, micro distribution fiber. And when I say multiple strands, I really mean a cable the size of a pencil. You could have 6, 8, 12, 24 different fibers. You get these really small cables that can have up to 96 strands. So you've got a huge pipe, a lot of capability from moving your signals from point A to point B. I usually get asked the question, well, what do you recommend? Okay, if I'm doing this pre-wire, what cable should I pull? It's really duplex at a minimum. And what we see, especially when you're talking about bulk cables, it's usually an OM3 cable, like we were discussing before. OM3 tends to be a standard. We're seeing a lot of OM4 now. If you can pull more strands to future-proof, great. You have that capability. But really pull duplex at a minimum. Now, just like twisted pair, there are different formats of cable construction that you'll run into, different jacket types, depending on your environment, your application. And this can get a little confusing, so I like to go over this. Now, most people are familiar with riser-rated cable. These are those in-wall cables, kind of your do-all everyday fiber that you run into general inside applications. Plenum cables. These go in those plenum spaces of those commercial environments, right, where we need a plenum rating above the drop ceiling or in the different crawl spaces. This is where the plenum cables come in. Now, what's cool about fiber is it is a really small cable. And the nice thing is you can have armoring that's also incredibly small. So again, a multi-strand cable that's the size of a pencil that has this helical stainless steel armoring inside the fiber optic cable, giving it immunity and giving it just extra protection against rough handling, punctures. You're getting into environments where, rodents chew on the cables. We see that in some different applications. The armored cable starts to really make sense. Now, direct burial cable should not be confused for a general outdoor cable. And this happens. People are, getting ready to put a cable outside and they have conduit pulled and they order a direct burial. You don't want to do that. A direct burial cable is made to go directly into the ground. It has a heavy armoring built into the cable to give it protection, and it's not going to pull through conduit very easily. Direct burial is made to directly be buried in the ground, whereas an outdoor cable is made for those environments where you will have maybe UV light, affecting the cable. You need a UV rating on the jacket. Water exposed areas. It's going in conduit in the ground that could fill with water. That's your general outdoor rating. And then really finally, a tactical cable. And ironically, a tactical, you think, hey, this is a little overbuilt, but actually tactical is the number one selling cable that we offer now in terms of a Premade. People are building these tactical cables for reuse applications, rentals, staging, broadcast, military applications, these applications where you're pulling out your cable and then respooling it. But because a tactical has built-in armoring, it is water resistant, it is UV resistant, it can go in the ground. It is a cable that's built for not only rough handling, but also those outdoor environments. Tactical is one of the most flexible multi-purpose cables you will run into. Let's turn our attention a little bit to connectors before we start getting into the actual how do I troubleshoot this stuff. Two connectors that you see in the AV installations. It's really the LC and the SC style connector. There are other fiber optic connectors. You will run into these from time to time, but they tend to be more data center focused, broadcast focused. LC and SC by far are the most predominant connectors you will run into. The difference between the two is really the size, okay? They're going to perform the same optical characteristics, same bandwidth. They even terminate in an almost identical manner. And if you can terminate an LC, you can terminate an SC and vice versa. Same process, okay? But the LC style, being a smaller connector, is what you're seeing now on most devices. This is the kind of connector you're seeing on SFP modules, which are what are going in the network devices out there, okay? So an LC connector is, odds are, what you're going to be using on most modern electronics, whereas that SC style, it's a bigger connector. It's what you saw on a lot of like the GBIC modules, the older networking equipment. You still see it on some devices. You know, be prepared to kind of be flexible between the LC and the SC. The good news is you can get a coupler that'll adapt them. You can get, you know, cables that'll adapt from one to the other, or you can re-terminate that cable. The next thing that you really want to take into account is, in your installation, are you looking at a bulk cable or are you looking at a Premade cable? A Premade cable, some people call these patch cables. Patch cables tend to be shorter distances, whereas Premades can be short distances. They can also be very long distances. I mean, we're talking about cables that are made to be, you know, pulled at 2,000 feet, 3,000 feet with the connectors coming from the factory, all pre-terminated. These are available. The advantage of a bulk cable is it's easier to pull, right? You don't have to worry about connectors. Now, the pull rating on a Premade, you know, it's still about 130 pounds, whereas that bulk cable, you're going to get a pull rating of about 200 plus pounds, 220 pounds. So you certainly have a very high pull rating with these fiber cables, and that's thanks to the construction. They're actually built with aramid yarn and or Kevlar, okay? But the other major advantage to keep in mind is the loss on a Premade cable is a lot less, and that's because you're using a fusion-spliced factory-made connector, whereas on a bulk cable, if you're not fusion splicing in the field, you're using a mechanical connector, there is a higher incidence of loss. So there's two things that you really want to take in mind. Some integrators love the pre-terminated. They love the fact that a cable shows up ready to pull. They just string it out. It's even got the pull mesh on it. Some people just standardize on bulk and they pull everything to length and terminate there in the field. Two different ways to do your installations. Electronics are another big factor, and we will talk about this in a lot more detail here in a minute, but it's very important when you're designing a fiber optic infrastructure to understand what's connecting to that cable. And there's two different ways that manufacturers will build devices, and it really will affect what your thought process is. So some devices have an external module for their fiber optic connection. And usually that's an SFP module or an SFP plus module, meaning that that fiber module can be popped out of the device and a new one can be popped in. And the reasoning for that is you get the flexibility of adapting the electronics between single mode fiber and multimode fiber. Okay? It's a hard thing to do with an internally connected connector, an internal module. Internal modules are fiber optic connections that are physically soldered on the board. Okay, these are physically mounted on the electronics board inside the product. Now, some electronics have these internal modules. We make them at TechLogix, right? And the product is still flexible enough to adapt from single mode to multimode, but we are an anomaly. That is not the norm. Usually a device with a hardwired fiber optic connector cannot be adapted from one infrastructure to the other. So you have to understand what's plugging into your fiber, understand what kind of fiber that it can work with, and make sure you're pulling the right cable. Now, the final thing that I want to talk about before we get into the actual troubleshooting point here and the troubleshooting parts is designing your system and what is in line. Because it is not the norm to just have a fiber optic cable with connectors on it. You plug your two devices in. Usually you'll have, a patch panel, or maybe a wall plate with keystone connectors, or maybe a coupler. There's a lot of different things that go in line in your installation. And all of those different things provide the incidence for loss, and loss can kill your system. We will look at that, how to deal with that here in a minute. Keep this in mind. It is important to understand the devices, understanding what you need in the middle, and making sure all that stuff in the middle is made for single mode or is made for multi-mode if that is the cable that you need to work with, and then put it all together into a functioning system. Let's talk troubleshooting. Okay, there's 4 things we're going to look at today, because when our team takes tech calls, it's really 4 different drivers 99.9% of the time that come into play. The link budget and the areas of loss, we will define that here in a minute. The connector termination, is it a quality termination? And if it's not, how can we tell? Clean connectors, another big one. This is a big question that we will often ask people. Did you clean the connectors? We will talk about that. And then the fiber optic bend radius. It does have an effect on the cable. But before we get into those parts, let's make sure you understand some of the terminology that I'm going to be using. So you'll hear 3 different terms getting thrown around: your loss budget, your power budget, and your overall link budget. Okay? The loss budget is the amount of anticipated signal loss on your cable run. So if you're doing an installation and you got some wall plates in line, you got a Premade patch cable, you got some bulk cable, you can do some math to determine what your loss budget is, how much loss you anticipate based on the different devices in line, the different installation accessories in line in your cable path. The power budget, on the other hand, is what is your device looking for? So your link budget, right, or your loss budget may say, based on all these factors, the long cable, I got a bunch of couplers, I have a loss budget of 5 dB, but my devices, my extenders are looking for no more than 3 dB of loss. You got a problem. Right? So you got to go back and you got to redo this installation, or at least this design. You got to understand what the anticipated loss is going to be and what the tolerances of your devices are. Put those 2 things together, and that's really your link budget, the link budget that you're working with. Now, the devices we see in these real-world installations are really, especially today, HDMI extenders, USB extenders, DVI extenders, we'll call them typical AV extenders. Those have a power budget. They can tolerate about 3 dB of loss. Same with AV over IP equipment that's fiber-based. It can tolerate about 3 dB of loss before you start to have issues. Networking equipment is far more tolerant. Networking equipment, at a minimum, usually can tolerate up to 11 dB of loss. There are some devices out there which can handle a lot more. I've seen these with 21, 22, 23 dB of loss, because what happens with a network device, if you got a bad connection, it doesn't die. It just slows down. Your performance will slow down. Whereas in an HDMI or a video environment, if you start to lose packets, you have a loss of signal. And a dropout in signal is what we would consider a catastrophic failure. You just can't have that. So the tolerance, that power budget for AV over IP devices, HDMI extenders, very different than the networking world. Now, what's going to create this loss, the incidence of loss? Mechanical connectors on your cable. Factory-made connectors, they even have some loss. Now, it's about half the amount of loss. As I mentioned before, a Premade cable is actually far more tolerant to loss than a mechanical connector is. Splices, wall plate, keystones, couplers, right? All of these different things in the installation, they have the potential to create loss. And this is what I meant by when you're starting to create your link budget, the power loss budget, the power budget of your different devices. What can they tolerate? What can my extender tolerate? And then what does my application really have in line? We can do a calculation and we can really find out what we should expect. So in this installation, right, this application that's on the screen, we have bulk wiring. We have a wall plate with a keystone. We have a patch cable. We have all these different things that are in line that come together, and our loss budget should be about 1.3 dB. Now, here's the thing. That is within the tolerances of our power budget for our extenders in this application, which is about 3 dB. Things should work just great. Now, when we get to the next part of this dialogue, taking your actual meters, if you have meters, and plugging them into the cable to see what your actual loss is. And if you find out it's more than 1.3 dB, now we need to start thinking about troubleshooting. If we're calculating we should be at 1.3, we plug in our meters and it says, hey, you're at 2.4, for example. Well, we've got something going on. Maybe we don't have a great termination, but 2.4 is still within our link budget, our power budget. But if we throw our meters on and we're at 5, 6, 7 dB of loss, now we got to start to troubleshoot, find out why. And how do we do that? Well, there's a couple of different tools we use. These are great things to have in our toolbox. For sure, you will use a VFL in every installation. That's a visual fault locator. This is basically an optical laser that you can see. Most devices, they're putting out a laser that is invisible to the eye. You can't see it. It will damage your eye if you look into it, so you don't want to do that. But a VFL, it's a visible wavelength of light. This is what's going to light up your connector and actually show you if you have a good termination. We'll talk about that here in a minute. And then you also have optical test kits. These are the meters and the generators that will provide you your actual amount of loss on an installation run. It's also what's used to certify a run, certify a cable path that it's within your power loss budget. So both tools are very useful. Let's start with the VFL. So a VFL, because it's a visual wavelength of light, it will illuminate any breaks in the cable. Okay, so if we've got a cable patch cord and, maybe we bent it too much and it snapped in the middle, the VFL is going to show us that. Now, here's the problem. In most, real world installations, these cables are going in the wall. Okay, so we don't necessarily have the luxury of seeing a break light up. And this is why you're seeing the rise of SSF grade fiber. Stronger, safer, faster. It's a polymer-coated cable that can literally be tied in knots. It doesn't break like traditional fiber optic cable does. It has a much tighter bend radius. We'll look at that here in a minute. In my opinion, the SSF grade fibers are what's making fiber optics deployable in the AV installation today. So it's just what we are seeing. It's what I recommend. You don't have to worry about those breaks in the middle of your cable because it's far more impervious to that. The VFL is also used to identify a poorly terminated fiber. And the way that works is these mechanical connectors, these good mechanical connectors, they have these locking tabs, and that locking tab doubles as a window. If you have a poorly terminated cable, right, there's an air gap in between the end of your fiber and the lens of your connector. That connector is going to light up, and light is bad. You don't want to see a lot of light in the connector window. That means the light's escaping, it's not getting to the optical lens. A well-terminated connector isn't going to have light present. The end of the fiber butting up against that lens, the light's going where it needs to go. So that VFL will really show you if you have a good termination. And that good termination is what's going to reduce your amount of loss. What about the meters? Okay, the next tool in your kit is really going to be the meter. A lot of installers don't necessarily have these to start out. They rely on the VFL, but as you're doing more fiber optic installations, it's a good idea to invest in a meter system for your crew. And these meters, they really start at about $500, so they're not terribly expensive. And basically what they do is you have a light source, which is going to generate your waves of light, right? And there's really two different wavelengths you're dealing with. In a multimode cable, and a lot of these meters are flexible enough to bounce between single mode and multimode. Some kits, you get two different meters, one for single mode, one for multimode. It all depends on what you're looking at. But the punchline is a multimode cable usually works at about 850 nanometers, whereas a single mode cable is usually looking at 1310 nanometers. And then that meter at the other end of the cable, it's reading this, right? It's reading the wavelengths. It's looking at how much loss you have. Now, here's the one thing that I always like to point out. It's really important to zero out your test equipment prior to any metering of a cable run, because one, you can have dirty connectors, and a dirty connector may be a problem with your meter because you're using it so much. Dust could get in there, oil from your hands could get in there. You want to zero that out. That's not reflective of your installation. The other thing is, I recommend that part of your metering process is using a patch cable, a Premade, to connect your meter to your fiber optic connector, the connector in your run. You can take your meter and directly connect it to the connector in your physical run. But one, it's not going to be that flexible. These meters, they're kind of bulky handheld devices. And two, every time you plug and you unplug a fiber optic connection, there's the incidence for wear and the incidence of getting things dirty. So really great practice is just using an inexpensive little, 1 foot, 2 foot, 3 foot little patch cable, zero that out of your system, and then you're good to go. So just a little process I recommend as you're working on metering. Let's talk about cleaning your connectors. This is a big deal, and this is a big tech support issue that tends to come in. People plug in all their installations. They know they got good connections, but they're having issues with their signal. Now, fiber optic equipment, couplers, SFP modules, extenders, all of these devices, they ship with dust caps. Okay? Best practice is keep the dust cap on the device as long as possible. It keeps the optical lenses clean. As soon as you take that dust cap off, you can get dust in there. You can get oils from your skin in there. You can get, all kinds of contaminants on those optical lenses. And because we're dealing with, wavelengths, light, we're dealing with lasers. You just don't want anything disrupting the flow of information across that optical lens. So best practice is to keep the dust caps on as long as possible. And if you need to clean the connectors, invest in a pen style or click style cleaner, right? These are small, inexpensive little cleaners. You literally just pop it into your connector, click it. It cleans that connector of any debris or oil or whatever it may be. Great little tool to have in the toolbox, but make sure those connections are clean. Final thing that I want to touch on here before we take some questions is fiber bend radius. This used to be a really, really big deal in those fiber installations, right? And if you ask people who were installing fiber a decade ago or, 15 years ago, they tell you fiber is incredibly brittle. And the problem is you might be pulling it, and if you you kink the line or you pull it too hard. It wasn't the fact that your fiber would break right away. It's that it would fracture and then degrade over time. It's kind of like your windshield, right? You get a chip in your windshield. It doesn't shatter the windshield right away necessarily, but over time that crack spreads. Fiber is no different. And what you'd see on these older traditional fibers is if you bent them too much, you get a microfracture. And that microfracture could lead to partial signal loss, right? A loss of signal affecting your performance. Complete signal loss if you completely fracture it, completely snap it, or what I consider is pretty bad failure over time, where you'd see that cable degrade over time. Now, SSF grade fiber, I keep going back to this because SSF grade fiber is actually a glass core that's wrapped in a polymer that just doesn't break like a traditional fiber. It means it has a 3 millimeter 0.1 inch bend radius. You can literally tie these cables in knots and they will still perform under stress. Whereas these traditional cables, they had a bend radius of about 30 millimeters. So it's night and day. And 30 millimeters, I mean, you think 1.1 inches, it's still pretty tight bend radius, better than a twisted pair cable for sure. But SSF grade fiber does perform better than a traditional fiber. It is new technology that's finding its way into the AV industry. Embrace it. It's my strong recommendation. But be cognizant of your bend radiuses in your fiber optic cables because it can create loss. So with that, I'm going to put my contact information up on the screen. You see my name here. You see my contact information. A lot of folks on the call may know me today. Feel free to call. Feel free to email with any information. You can visit our website. The video of this recording is available on the website, as well as a bunch of different webinars and training sessions that we have done in the past on a variety of different topics. At this time, I would encourage you, if there are any questions, you can go ahead and type those into the GoToWebinar widget box. There's a little question tab. You can type in your questions now. We will try to get to those. Give it 1 minute here for folks to type their questions in. Don't see anything coming in, so I take that most of the questions were answered on the call today. If there are questions afterwards, again, feel free to reach out. I appreciate everybody's time today and hope you have a great rest of your day.